Hi dear students, today in this video we are going to discuss about negative transformation and matrix of linear transformation. So using linear transformation or using linear mapping, uh, we can form the matrix also. Okay, so that we are going to discuss over here. Uh, Let us discuss. So, if you look into the definition of negative transformation, maybe they can ask for 2 marks. Okay. So, T is a mapping from the vector space U to V be a linear transformation. Then the mapping minus T. See, negative transformation we are discussing. So, this is how we are denoting the negative transformation as minus T, defined by minus of T alpha is equals to minus T alpha for all alpha belongs to the vector space U is a linear transformation. Then we can say that it is this mapping is a negative linear transformation. And how we are denoting minus T, right? Negative linear transformation of this T. Okay, so this is definition of negative linear transformation. Next we are going towards matrix of linear transformation. So this is very important concept. Maybe they can ask for 2 marks definition, and examples they will ask for 2 marks as well as 4 marks. So let us discuss the definition of matrix of linear transformation. Let the vector space U and V over a field, that to same field, we can say that capital F, we have taken it as a field with ordered bases. So these are the ordered bases. This one B1 is a ordered basis. Why we have taken? See how we have taken the ordered basis. B1 is equals to alpha 1, alpha 2, alpha n. These are ordered, right? So these are ordered. So B1 and B2 we have taken ordered basis, beta 1, beta 2 up to Bn respectively. Then the linear transformation from the vector space U to V and the element Aij, which is belongs to the field capital F, such that transformation of every element of base, first base and second base, how uh, will get the combination of the elements of Aij as well as the ordered bases. So that we are going to discuss over here. How we need to form the matrix using this linear transformation. So that is the main motivate behind this definition. So T alpha 1 transformation of alpha 1 is like this: A11 beta 1, right? A21 beta 2 and so on, AM1 beta m. Say, if you observe this transformation of alpha 1 is what? Element of the ordered base. Okay, so the transformation of the alpha 1 is A11 beta 1 plus A21 beta 2, I can write down, plus so on AM1 beta m in general. Same thing for T alpha 2, A12 beta 1, A22 beta 2 plus so on plus AM2 beta m. Like that, T of alpha j is A1j beta 1 plus A2j beta 2 plus so on plus AMJ beta m. See, you need to remember this definition, right? It will be useful for solving some examples. T of alpha n is a1n beta 1 plus a2n beta 2 plus so on plus amn beta m. Okay, so if you observe this, the transformations of alpha 1, alpha 2 up to alpha n, how we are forming this one? See, if you observe according to the matrix, how we'll get it? How the elements are looks like a11 row wise, a12, right? a13 like that, right? a13 like that. Okay, so same thing, if you observe, the row becomes here the coordinate points. If you observe the beta 1 coordinate points, so these are the elements of what? Row. So here second row, this one is second row, this one is third row. So while solving the examples, you'll get to know how we need to form the this transformation. It is totally depends upon the example. Okay, so how they have defined the transformation, that also depends. Okay, so next, if you observe this, writing coordinates of t of alpha 1, t of alpha 2 up to t of alpha n successively as a column of matrix, we get, see here, so these coordinate points a11, a21 up to am1. So if I write it in column wise, row becomes column wise. So column matrix, if I write down here, see here, a11, a21, a1, ai1 and up to am1 will get it. So after this, I can represent this matrix as aij, that to what? M cross n. So this is how we need to transfer the linear transformation to matrix. Okay, so it's called the matrix of linear transformation. Okay, so important note, if b1 equals to b2 is equals to b, then matrix of linear transformation is this one. Okay, so transformation with the base b, b1, b2. If I have taken two bases, that two equal bases, if I have taken, then that linear transformation, matrix of linear transformation is same thing will get as b. So any matrix A is equals to aij m cross n over a field F determines a unique linear transformation, that is what T of alpha j is equals to summation over I is equals to 1 to n aij into beta I, where j is running from 1 to n over a vector space from U to V with a matrix A. So same thing, this is also represents what we have discussed in this step. So we'll get this step, summation over I is equals to 1 to n, so aij beta I will get it. Okay, so let us discuss some examples based on matrix linear transformation. So find the matrix of linear transformation. So they have defined the linear transformation over here, that to what? V2 of R to V3 of R defined by T of xy is x plus y, x 3x minus y with respect to a standard basis. So what we need to find out here, we need to find out the matrix of this linear transformation, and with respect to what we need to consider the standard basis. Okay, so let us discuss how we need to form the matrix when they have given the linear transformation. So first of all, we need to take the standard basis. Okay, so for that, let E1, E2 and F1, F2, F3. See, E1, E2 R belongs to this V2 of R, and F1, F2, F3 R belongs to V3 of R. So these are the standard ordered basis of V2 of R and V3 of R respectively. So standard basis means E1 is equals to what we'll get 1 0, E2 is 0 1, and for F1 1 0 0, F2 is 0 1 0, F3 is 0 0 1. Right? Now transformation of alpha 1, if you observe the definition of matrix of linear transformation, T of alpha 1, right? They have given the transformation now and they have given the basis, two basis, right? So this is V2 of R basis and this is V3 of R basis according to example, okay? So T of alpha 1 we need to find out now. T of alpha 1 means here T of E1, first base, okay? So first base we have taken E1, E2, this one is B1. If I, according to definition, if you observe, it is a B1 and it is B2, okay? So like that we need to consider. So E1 is equals to, we have 1 0, E2 is 0 1. Now we need to find out the transformation of E1. Why we need to consider E1 only? According to the transformation, what we have, V2 of R to V3 of R. So V2 of R means it contains E1 and E2 elements, okay? So E1, E2 elements. So therefore T of E1 is equals to, so E1 is already we have taken 1 0, this one is a standard base. So transformation of 1 0 is equals to, according to the definition what we have, transformation of 1 0 if I take. So in place of X 1 is there, in place of Y 0 is there. Put the values, we'll get 1 plus 0, 1, 3 into 1 minus 0 will get it. So 1, 1, 3. So transformation of E1 is equals to 1, 1, 3. Now we need to write it in combination of second base, okay? So like this we need to write down, see like this, combination of the elements and the elements of bases 2, okay? So if I observe the second base, the elements of second base are F1, F2, F3, okay? So transformation of 1 1 3, sorry, transformation of E1 is 1 1 3. So this 1 1 3 I can rewrite it as 1 into F1 plus 1 into F2, 1 into F1 plus 1 into F2 and 3 into F3 I can write down, right? So this acts as what? A11, A21 and this one is A31, okay? So like that, same thing for transformation of E2. So transformation of E2 value is 0 1, right? So if you observe, this acts as X and this acts as Y. So according to the definition of transformation, X plus Y we have. So X plus Y means 0 plus 1. Next we have X value is 0 over here, so 0. And next 3X minus Y we have. So 3X minus Y means 3 into 0 minus 1. Okay, so 1 0 minus 1 will get it. So therefore how we can write down? 1 into F1, 0 into F2 minus 1 into F3. So what we have done, according to the definition, if you observe the matrix transformation definition, matrix linear transformation definition, we have formed this one, right? So after forming this one, this row becomes column. So column wise we need to rewrite. So that if I write down in the column wise, then I can say that it is a matrix. So see here they have given column matrix. We need to write coordinates of T of alpha 1 and T of alpha 2 up to T of alpha n. So coordinate points we need to write it in the column wise. So according to that definition, if I write, see these are the coordinate points, 1 0 minus 1 are the coordinate points. So here 1 1 3 are the coordinate points of T of alpha 1, T of alpha 2, right? So what we need to do, we need to write in column wise. So therefore here 1, 1, 3, it is in the row form, right? So we need to write it in this form, column form. Okay, so 1, 1, 3, 1, 1, 3. Next, here 1, 0, minus 1. So it is also in the form of row wise. So we need to write it in column wise. So 1, 0, minus 1. So this is how we need to find out the matrix of linear transformation when the linear transformation is given. Okay. So next example, if you observe, find the matrix of the linear transformation V2 of R to V3 of R they have taken, defined by, how they have defined, 2y minus x, y, 3y minus 3x relative to basis. See, they have not given standard basis now, right? If it is in standard basis, definitely it will be easy, but they have given other basis. So B1, how they have given 1, 1, minus 1, 1. B2, 1, 1, 1, 1, 1 minus 1, 1, 0, 0, 1 they have given, right? So now we need to find the matrix, right, of this linear transformation. Okay, so let us see how they have solved it. So we have T of xy, how they have defined, 2y minus x, y, 3y minus 3x. So now we need to find out, this one acts as what, alpha 1. So we need to find out transformation of this base. Okay, so T of alpha 1, T of alpha 1 means 1, 1 we have. So according to the definition, 2y minus x we have. In place of y we have 1, in place of x we have 1. So therefore 2y minus 1 is nothing but 1. Next 1. Next 3y minus 3x we have. So 3 into 1 minus 3 into 1, 0. So this transformation of 1, 1 is 1, 1, 0. Same thing for transformation of 1, 1 is 1, 1, 0. So therefore I can rewrite. How I have to write? According to the definition of matrix, we need to combine, right? We need to combine both. So suppose if I take A1 is a coordinate point, A2 is a coordinate point, and A3 is a coordinate point, right? So then this second base, combination of second base, we need to write, no? So 1, 1, 1, 1 minus 1, 1, 0, 0, 1. So this is the transformation of 1, 1, 1 is 1, 1, 0 is equals to, I can write down this one. Okay, now we need to find out the value of A1, A2, A3. Okay, so if I find out the value of A1, A2, A3, definitely we'll get it, the matrix. So same thing for the second base, second element of first base, T of minus 1, 1. So this is alpha 2, T of alpha 2, right? So T of alpha 2 in place of x, minus 1, in place of y, 1 we have. So put the values, definitely we'll get the coordinates of T of 1, 1, minus 1, 1 is 3, 1, 6. So again, so these are the coordinate points, right? So if I take B1, B2, B3, right? So combine the second base, we'll get B1 into 1, 1, 1, 1, B2 into 1 minus 1, 1, plus B3 into 0, 0, 1. Here A1, A2, A3 and B1, B2, B3 are the coordinates vectors of T1, 1 and T minus 1, 1. That only we have told you. So relative to basis B2. So therefore the matrix of T is A1, A2, A3, B1, B2, B3. See here, it is in the form of row form. Row wise it is, so we need to write it in column wise. Same thing for this one, it is also in the form of row wise, we need to write it in column wise. So therefore A1, A2, A3, B1, B2, B3 is our matrix, but we don't know the value of A1, A2, A3 and B1, B2, B3. We need to find out the value of these A1, A2, A3 and B1, B2, B3. So To find A1, A2, A3, consider uh, to find A1, A2, A3, consider the equation A1 with the coordinate points of second base 1, 1, 1 and plus A2 1 minus 1, 1 plus A3 0, 0, 1 is equals to the coordinates of T of alpha 1. T of alpha 1 we have 1, 1. So coordinate points are 1, 1, 0 here. So equate them. Then obviously we'll get A1, this A1 plus A2 plus 0 into A3 is nothing but 0 is equals to 1. So A1 plus A2 is equals to 1 we got. Next, for same thing, A1 into 1, A1. Next, A2 into minus 1 is nothing but minus A2 is equals to, we have 1. So A3 into 0 is 0. So therefore we'll get this second equation. Next, third one, if you observe, A1 into 1 and A2 into 1. Next, A3 into 1. That is nothing but A1 plus A2 plus A3 is equals to 0. So this implies, if I simplify these equations, definitely will get the value of A1, A2, A3. So if you simplify these two equations, okay, A1 plus A2, A1 minus A2, right, is equals to 1 is equals to 1 we have. So these two terms will get cancelled. Only will get 2A1 is equals to 2. A1 is nothing but 1. So put the value of A1 in the second equation. We'll get A2 value as 0. A3 value, A1 value we have, A2 value we have. So put the values in the third equation. Definitely we'll get A3. So minus 1 we got. Similarly, I can find out the value of B1, B2, B3. So after finding the value of B1, B2, B3, and already we have A1, A2, A3, put the values of A1, A2, A3 and B1, B2, B3 in the matrix, we'll get the matrix of linear transformation. Okay, so this is how we need to form the matrix from the linear transformation. Okay, so this example again same thing. So go through these examples. I will not discuss much on these examples. Okay, so if you have any doubt or any queries, you can ask freely. You can contact me. Okay, so I will stop over here, and next class will continue. Okay.